Algebra 2 Cram, New York State Algebra 2 Regents, Common Core, Logarithmic Formula, Memorization, Basics. Concept number 8, the power rule of logarithms, log base b of x raised to the c. So, the odds of someone doing exactly what you tell them to do is pretty slim, but I guarantee that if you cram with me, you'll become an Algebra 2 master. What we're doing here is effective. I'm coaching you to turn your wants and desires of getting an A or perfect test scores into a new paradigm. And if I could stick every single math student with a syringe containing a healthy dose of eye-opening awareness of their inner mathematical genius, I probably would. I want to include everyone who needs this boost in Algebra 2. So inbox me at memedicine@gmail.com to get your healthy dose by ordering the complete cram session beyond the logarithmic formula memorization basics. You have lots of peers, classmates, and or colleagues who could really benefit from purchasing this cram session as well. So be sure to spread the word and tell them to inbox me at memedicine@gmail.com. Let's delve into the concept. Logarithmic formula, power rule. Solve the log base b of x raised to the c. Definitely press pause if you need to, and I'll give you a moment to think. All right, so hopefully by now you are able to press pause and come up with a formula. And if not, that's completely fine. Okay, so what we're going to do now, before demonstrating how to arrive at the formula for the log base b of x to the c, is first understand the general format for an exponential function. Okay, because exponential functions are the basis for all logarithmic functions, hence logarithmic formulas. And the general format for an exponential function is y is equivalent to b to the x, okay? Where b is positive, so it's never going to be negative, and it's not going to be equal to 1. These two instances can occur, just not for our logarithmic functions, okay? And so in the general format, b is the base, it's going to be the constant, and the exponent, x, is going to be our input or independent variable, and y, or the result of this exponent, is going to be called the power. Now sometimes the names power and exponent are interchanged. This is actually a misnomer because let's say that the value of x or x were assigned a value of 2. You would have the constant or the base b raised to 2. Well, what we could say is that the result is the second power of the constant b, okay? Yeah, so that's how you use that naming system. And don't confuse this format with a polynomial function because exponential functions, again, have the base as the constant, okay? In a polynomial function, the base is the independent or input variable, and the exponent is the constant. This is a depiction of what an exponential function is going to look like, all right? Yeah, and so now let's get on with the definition or features of basic logarithmic functions. A logarithmic function is the inverse of the corresponding exponential function with the same base. Okay, what that means is that this is how you express a logarithmic function. Y is equivalent to the log base b of x, okay? But for people seeing this type of notation for the first time, it's a little confusing or they become dumbfounded. So what I'm going to do is show you the equivalent expression in exponential notation. So an equivalent expression for y equals log base b of x is going to be x equals b raised to the y, okay? And whenever you see a logarithm, it's easier to think about the equivalent exponential form in your head. And remember that algebraically, again, in order to yield the inverse function of your starting function, what we're going to do is switch the independent and dependent variables, hence yielding this expression. Or simply put, we switch the position of the x and y values, okay? So for this or any inverse functions, the constant of your starting function is going to be this constant in your inverse function, hence the name constants. Constants remain constant. You can't, switch them up. But now x represents the power or the result, and y holds the place of the exponent. And on a coordinate plane, the logarithmic function is the reflection of the graph of the exponential function over the line y equals x. Okay? And here goes our logarithmic function after we flip our exponential function or we reflect it over the line y equals x. All right, so that was an intro to the logarithm function. So in the case of log base b of x to the c, it turns out that the formula that's equivalent to this is c times log base b of x. And I know what you're probably thinking. Prove it. Justify this result on the right-hand side. Okay, so what we're going to do is sort this out first by doing some relabeling. And we can re-express this portion of the formula. And so we're going to assign this a value of m. So m is equivalent to the log base b of x because we're assigning that value, okay? So algebra isn't always straightforward. There is a lot of manipulation, and the more you do, the more you know how to manipulate. We can also look at this m as our, our dependent variable, okay? Or in this case, our power. So if we convert this logarithmic expression to exponential notation, we can re-express it as x equals b raised to the m, okay? So yeah, now the m is holding the place of the exponent. All right? And now what we're going to do is raise both sides of the equation to the c power. So x to the c is equivalent to base b raised to the m raised to the c. Okay? Hope you're not tired mentally yet. It's almost over. And now let's try to reconstitute our original expression or the original concept by taking the logarithm of both sides of this expression, okay? So we have the log base b of x to the c is going to be equivalent to the log base b of b raised to the mc. And remember that from properties of exponents that if you're raising an exponent expression to another exponent, you simply multiply those exponents. That's why they're grouped on the left-hand side, okay? All right. And before moving on, let's take a little detour. I want to introduce you to something called the cancellation property of exponents, which says that if you have a log base b of a base raised to an exponent, this is just a fancy way of saying the value of the exponent. which in this case is going to be x, okay? And this makes sense because in the introduction up here, we established that the logarithm function computes the exponent, okay? You're raising the base b2, all right? And well, here, the formatting that we're shown, we're actually told the exponent or the answer without having to try to decipher or figure anything out. So we're told what this is in essence, and we just make that our answer, okay? Now, getting back on track using this cancellation concept, if you're still not clear on this, email me. I'll try to clarify it better. But we're going to use this cancellation properties of logarithm to say that the log base b of x to the c is equivalent to m times c, okay? Because basically we're canceling out the base. Or in an effort to figure out y or our exponent, we're kind of told what our exponent is, which is m times c. So we write that out here. Now we can go back and undo the labeling. We assigned m the value of log base b of x, okay? Therefore, the log base b of x to the c, and it's okay if we reorder these because in multiplication order doesn't matter. So we're first going to write out our c times the value of m, which is the log base b of x. And we see that this formula corresponds to this formula, and that's our answer. All right. Yeah, so you're probably asking, okay, like what's the point of all of this? Well, knowing how to interconvert these logarithmic formulas is relevant because in an effort to solve a bigger equation, knowing alternative values for either the left-hand side or right-hand side can be used to simplify and manipulate equations. So commit this formula to memory, and overall intellectual comprehension of this material was not difficult. And after the short amount of time it takes you to complete the entire Cram session, you'll be able to answer a battery of questions about anything in Algebra 2. So inbox me at memedicine@gmail.com to purchase and order the complete Cram session. Well, order and then purchase the complete Cram session, okay? All right, good luck studying. I know you can do it.